Thank you, Peter. First of all, I'm asked by my ministry to welcome this conference to Bergen and to Norway. The Ministry of Fisheries and Coastal Affairs are very pleased that you took the opportunity to arrange this in Bergen. I'm giving the title Monitoring and Management of Ocean Resources in the High North. First of all, I would like to start with a short and brief introduction of Institute of Marine Research. We are a governmental institute owned by Ministry of Fisheries and Coastal Affairs with the purpose to produce and secure the scientific basis for the management of the Norwegian oceans and Norwegian sea areas. We also have a very demanding task, and that is to develop technology for fisheries and catching. And this is not just the catch technology. This also includes survey technology, monitoring technology, acoustics, and whatever technology we need to secure a scientific basis. We are, like Peter said, a national institute placed all around Norway, and not showing on this map as we just opened it, we also have a very small office in Svalbard. Part of our activity happens in Southern Africa, Asia and South America, where we are working together with other countries in developing fisheries and marine sciences as well as marine management. We are running several research ships, and actually these days we are starting to finalize the contracts of building of 2 new research vessels, one ice-going and one who is supposed to be operating on the southern hemisphere. The outline in my speak, I will first start with a little background on facts and assumptions. Then give a short comment on monitoring and management. The first thing I would like to do is, when we are talking about the High North, we need to focus on the A5 countries, Russia, USA, Canada, Greenland, and Norway, who has borderlines to the Arctic Ocean. And this ocean is rather interesting from a biological point of view, due to the fact that you have shallow oceans along the coastline and you have a deep Arctic Ocean, who's largely not explored. We do not really know what's down there. We also have a map of fishing intensity in the Arctic. As you can see, it's the shallow waters close to the Arctic Ocean that fishing activity has been carried out up to now. And this may be important when we are talking about the management of these areas. When you look into this slide again, you can see that Russia has a huge area. Canada is the second largest, followed by Greenland, Alaska, US, and Norway. And that management raises several rather important questions. I will come back to that. When we look upon the Arctic sea ice conditions, this is a picture taken on the 19th of January this year. And you can see how little ice there really is present in this area. And when we move to the sweeper 2011 executive summary, we find that the Arctic Ocean is projected to become nearly ice-free in summer within this century, likely within the next 30 to 40 years. And this raises a lot of questions on how climate change will affect both fisheries, both other industrial activity in this region. When we look upon the climate impact on fish stocks, we already see several effects. We know that climate will have an impact on individual growth, on recruitment, and not at least important, distribution and migration. We also see that we have new species entering the Arctic area, following by climate change as well as by man-made introduction. And we know that this will have an impact on the life and the ecosystem in the high north. How climate affects species directly and indirectly is another key question. And we know that temperature, currents, transport, stratification, mixing, and light are the dominant factors for affecting the ecosystem, starting with phytoplankton over to zooplankton, and then pelagic fishes and larvae, demersal fishes, and then seabirds and marine mammals. This is a chain that is already affected by climate change, and it will continue to be affected in even a stronger way. And the key question is, do we monitor this good enough today? Are we satisfied with our ability to monitor the change? And the answer to that question from a scientific point of view is a clear no. We do what we can with limited resources, but we are not able to forecast any kind of point of change, and not at least important point of no return. Warm currents give productive sea areas. And what we see is, of course, that fish and other species will follow the temperature. And this is a rather important picture showing what will happen through the currents. Taking a few slides regarding on some fish distributions over a couple of years. First, to start with the pelagic species, the capelin. And this is the measures or surveys done by IMR and the Russian Marine Institute PINRO in 2003 and 2012. And here you are able to see how the migration of capelin has changed. Why is that? It's because it follows the food. And what we see is that it is slowly moving north and east into areas earlier covered by ice. It's dependent on the food source. And will we see an increasing migration? Well, we do not know. It's dependent on the plankton blooming season. Will there be enough temperature? Will there be enough light for plankton to migrate? When we then move over to the demersal stocks, what we have here is the distribution in autumn 2012 of cod and haddock. If we had a slide of the 2003 year distribution, you would have found that it stopped approximately here. We have experienced commercial fishing activity up on the 80-degree north. And that, to our knowledge, has never happened before. And that's got something to do with how the temperature is changing, how the area for industrial activity is changing. And when you add on the oil activity, which probably will happen in this area, then you can see we have some challenges regarding the ecosystems. What then about other species? When we look upon the redfish, you see here a hypothesized expansion of the distribution area of redfish and a future ocean climate. The shadowed area given here and arrows indicate current distribution areas and migration routes. Plain color areas and arrows indicate potential future. So what you see, there's a change on where the fish distribute within the waters. And we even have more candidates. We have Greenland halibut already on the northern shelf of the Bergen Sea, and it may migrate further east. Whales, we probably will see more whales, more frequent, if the food is available. On the other side of the Polar Sea, regarding the Bering Sea, here you're able to see the distribution, the main shift throughout the years. And you see the same pattern as you see in the Bering Sea and on our area, our side of the Polar Sea. I was talking about oil activity, and one thing that we are very concerned about is what's happening with oil activity, what's happening with oil spill in the water, regardless if it comes from oil drilling, oil production, or shipwrecks. I just want to show you a very small example of a study we did, and that oil droplets in water on cod larvae. And here you see a high concentration of oil droplets, and what you see here is a cod larva with an empty stomach compared with a control group with a stomach contact of food which is full. And obviously this has got something to do with the ability of larvae to survive an oil spill situation, regardless of the source of the oil spill situation. And this leads to some concluding remarks. The north and eastward movement of species will depend on density distribution, temperature, and food conditions. Only pelagic species will potentially move into the deep Arctic Ocean, and that's got something to do with the food. We do not believe that cod, haddock, or other demersal stocks will find food in the deep waters. They do not do in the Atlantic. They will not do in the Polar Sea. Dependent on the occurrence of plankton, we may have distribution of pelagic stocks. And most likely, we will have no fishing activity in the Arctic Ocean in the coming 10 to 15 years. And that's simply because there may not be fish. We will definitely have fishing activity on the shallow areas surrounding the deep Arctic Ocean, we think, but we will not have any large activity within the Arctic Ocean itself. I will then try to move over to the monitoring side. What we do have is the Agro program. And this map shows the Agro coverage throughout the world. As you can see, there are some Agro bios up north on both sides, but very, very little. And it may be a challenge to see, are we able to produce bios that can operate in these waters, at least when it's ice-free. In addition to that, we do a lot of marine monitoring. What I've shown here is the full coverage that we do within the ICES system. And this is a joint international project with many ships taking trawl stations, doing sections, taking oceanographic research. These sections show the oceanographic sections we are doing at IMR together with the Russians. And this section, the Kola section, is, as far as I know, the world's oldest oceanographic section. And quite honestly, this is more valuable than much of the gold in the world. Because this is saying something on how things are changing. The speed, how rapid things change, and what to do. We have set up 2 slides, 2 more sections up here, and we intend at Ieee to move the sections further north as the ice is retracting. This is time-consuming, costs a lot of money, but I have found it necessary to prioritize it due to start to build time series further up north. We also have a Norwegian initiative called INORD, or the Barents Watch. And this is an integrated system for surveillance of the Arctic Ocean. And this is a rather new initiative. And the idea with it is to start to use satellite, all other possible sources to get information, to be able to produce a better management system, to get whatever possible data we can get to secure that we are able to take the right management decisions. In addition to this, we have in Norway, I have not a slide on this, but we have in Norway a huge mapping program for the first time covering the Barents Sea, and that it's called Mariano. And that's a sea bottom mapping project that covers the sea bottom both from a bottom mapping system as well as to see what's on the top layer of the bottom as well as what's down there of biology. But then about future monitoring systems. I think that whatever we do, we need to challenge the technical societies, because in no way we will be able to afford or have the capacity to do monitoring, to do surveys by ship time only. We need to develop more technical solutions for monitoring. That's one part. The other part is that I cannot see that any nation can carry this alone. And that means that we need to have an international collaboration when we are talking about monitoring. I think we will have different and several technical solutions for monitoring. The first important is fixed stations, cable networks. I have one reference here called the Lofoten Vesterålen project, a LOVE project, run by Ieee and Statoil. If you contact the staff at our poster in the exhibition area, you'll be able to learn more about that. Olav Rune Gode is the man. Another interesting project, international, is the thing that Professor Martin Taylor is doing on the west side of Canada, starting to try to cable the shelf there. And then we have the moored buoys, Station M, which is a project run by Ieee, also utilized by University of Bergen, as well as Meteorological Institute, on a fixed position in the Atlantic, North Atlantic. We also have seen that China has put up a buoy up there. So far we have not got any data from that buoy, but we hope that they will share the results, the measuring they are getting from that buoy with the rest of the world. And what's more interesting may be the acoustics. Use of low-frequency acoustics may cover areas not today covered. They may give us information that we do not have today. MIT and Ieee are working together on a joint project using low-frequency sonars to develop or to try to start monitoring what's in the seas. I think that acoustics, there's a long way to go, but I think acoustics may be one of the most important areas for monitoring seas, monitoring what's in there, and be able to get data in a cheaper, better way. We also have AUVs, we have satellites, and we have drones. I think that if you're able to launch international composed project, utilizing what technology can give us, we may be able to monitor to a large greater extent than we are able today. We are a biological research station, a research institute. I would like to give a challenge to you to cooperate with biological research institutes to see how can we develop monitoring systems that are able to live with technical solutions to give us more data than we have. When I then move over to management, the key factor for me is sustainability. And I would like to emphasize what the Brundtland Commission in 1987, 26 years ago, said. Sustainable development is a development that meets the needs of the present generation without reducing future generations' possibilities or abilities to meet their needs. And this is a key factor. 2 years ago in Kyoto, on a conference there, Science, Technology and Society, there were a couple of Nobel laureates who stated that the challenge to sustainable development may be the economics focus on the bottom right corner and hiding the value created, hiding the science created, and hiding the ability to produce enough for everybody. That may be a challenge. I will not go further into it here. When we look upon management, it's necessary again to put out these boundaries. Who owns the Arctic? Is this the A5? No. It's the rest of the world? Yes. What do we do then to manage this huge area in a sustainable way? And I think that we have some organization that may help us in that way. We have regional cooperation through the International Arctic Science Committee. And that's an operational, very good science committee that's working well. We have the Arctic Council, still trying to develop new members. Unfortunately, the EU didn't become a member or became an observer status due to some discussions with Canada and the hunting of seals. That's an issue I shall rest for today. And then we also have the Bergen region, and we have a large number of bilateral agreements. Nevertheless, this underlies the fact that there is a strong need for international collaboration. And we have some management dilemmas. In this slide, I used fish as an example, because what we see is that we have a trend run by NGOs moving towards conservation for use, seafood from sustainable harvest of living marine resources versus the conservation for protection. And it's a political choice, or choice that has to be made by society. And we cannot talk about developing in the high north without putting focus on sustainability and whether we want to live off the resources from the sea or not. So therefore, management advice is related to the ability to predict future development. And the real answer to management is you need to have science as a basis. Otherwise, you think, you assume, and you've got some ideas. When high-ranking politicians doubt that we have a climate change, you may wonder why. And we as scientific community need to answer what-if questions. It's a matter of estimated couple effects. It's a matter of daring to say something about threshold values. Advice by its nature is operational. That means that in 5 years' time you may get a different advice. That's the nature of science, that's the nature of natural sciences. So therefore, management in the high north. We need management regimes with sufficient capacity in terms of robust science, regulatory frameworks that contribute to sustainable human activity, enforcement capability, and that is more likely to respond to adequately to changes produced by climate change and human activity in the north. It's a simple recipe, but do we dare to make the cake? That's the key question. Do we dare to ask the oil industry or other industry, what are you really doing? What's the content of produced water that we pull into the sea? So therefore, my conclusion is, the observed biographic distributions of the species could be explained by life history, characteristics and development rates coupled to water temperature, length of growth season, and advection. That's the biology. We need more and better technical solutions for increased monitoring of the high north. That's a challenge to the technical society. The high north requires increased international science as basis for management, and the science need to be international to be recognized by several states. And then, at the end, we requires a sustainable management approach, in my opinion, given by building on the definition given by the Brundtland Commission. Thank you very much for your attention.